The devil is a liar. The devil is a liar. The devil is a liar. Who is back with us again? Who is back? Who is back? Who is back with us? Who is back with us? Who is refusing to give up? Who is back with us? Who is back? Who is back? Who is back with us? Who is back with us? Welcome back, welcome back, welcome back. This class must hold. My network is usually very, very strong. My network is usually very, very strong, but today, this class must hold. This class must hold. This class must hold. If you can see the board, if you can hear me clearly, let me know now. Let me know now. Let me know now. Let me know now. Can you hear me now? 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 Yes. Welcome back. Welcome back. Welcome back. Welcome back. Welcome back. Welcome back. Can you see the board? Can you hear me? Can you see the board? Can you hear me? Can you hear me? Can you hear me? Good, 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 good. Is the board clear? Is the board clear? Can you still hear me now? Can you still hear me now? Just to confirm that you can hear me, I want to know if you can hear this last type electrode in the comment section. Type electrode. Type electrode in the comment section. Type electrode. Electrode. Type electrode. Type electrode in the comment section if you can hear me. Type electrode if you can hear me. Electrode. If you can hear me, type electrode. Good, 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 good. Can you see the board clearly? Can you see the board clearly? Can you see the board clearly? If you can hear me, type electrode. If you can see the board, let me know. Type electrode if you can hear me. If you can see the board, let me know. Type electrode. Type electrode. If you can see the board, let me know. Let me know, let me know, let me know, let me know, let me know. You're all welcome back. Those that keep coming back, well done, well done. That's the energy you should have. Well done. It means that you are really ready to pass your JAMB. You are really ready to pass your JAMB. Yes. Well done, class. I like this set. I love this set. I love this set. This is the energy we need. Someone says, sir, continue. It's clear now. Let's give it a few minutes before we rush and go and start teaching again. You can still see the board, right? Okay, someone said it's clear. It's clear. That's the energy. Good. That is the energy. That is the energy. Good, good, good. So where did we stop? Someone should type. Type in the comment section. Where should I continue from? Type in the comment. Where should I continue from? Where did you stop understanding? Where did you stop understanding? Where did you stop understanding? Okay. Okay. Let's go. So every once in a while, I will come to the phone to check if it's still clear and if you can still hear me. Class. I was saying that anytime there's an increase in oxidation number, there's also a decrease in number of electrons. Anytime there's an increase in oxidation number from 0 to +1, there's also a decrease in a number of electrons from 11 to 10 electrons. That's what you take note of. Now, let's look at it on the other hand, class. Let's look at chlorine. Chlorine is 287. What happens when chlorine gains 1 electron to become 288? Currently, chlorine has 17 electrons. This chlorine has 18 electrons. Class, in chemistry, when an element gains electron, it becomes negatively charged. In chemistry, when an element gains electrons, it becomes negatively charged. The number of electrons it gains is what it will carry as a negative charge. So chlorine gains 1 electron, that's why it's -1. And if it gains 2 electrons, it will be -2. If it gains 3 electrons, it will be -3. In chemistry, when you are gain, you are minus. When you lost electron, you are plus. I'll come again. When you gain electron in chemistry, you acquire a negative charge. When you lose electron in chemistry, you acquire a positive charge. So chlorine gained 1 electron to become Cl-. Now, is this equation balanced or not? Let me know in the comment section. Is this equation balanced or not? Let me know in the comment section. Is this equation balanced or not? Is this equation balanced or not? Someone said balanced. Someone said not balanced. Class, is the equation balanced or not? Class, it is not balanced. Class, normally the number of atoms here is 1 chlorine, 1 chlorine. But like I told you, when dealing with ionic equations, you are not just balancing number of atoms. You are balancing number of charges. Total number of charges on the left-hand side must be equal to total number of charges on the right-hand side. Class, total charge on the left-hand side, this chlorine has 0 charge because it's on charge. It's not carrying any charge. The charge on this chlorine is 0. But the charge on this chlorine is -1. So class, the charge on the left-hand side and right-hand side must be equal before you say the equation is balanced. Before you can say an equation is balanced, ionic equation is balanced, total number of charge on the left-hand side must be equal to total number of charge on the right-hand side. Total charge on the left-hand side is 0, total charge on the right-hand side is -1. Therefore, this equation is not balanced. So class, to balance this equation, we use electrons. Class, notice that this chlorine has 17 electrons, this guy has 18 electrons. Class, the side of the equation where you have the less electron is where you are going to add electron. Class, you have 17 electron here, you have 18 electron here. It means that there is 1 electron missing on this side of the equation. So we're going to say plus 1e minus. Plus 1e minus. So that if you now look at it now, total charge on the left-hand side is now, each electron comes with a -1 charge. Electrons are negatively charged, class. So anytime you add an electron to any side of the equation, you just introduce -1 charge. So this 1 electron has introduced a -1 charge to this equation. Ensuring that the total number of charge on the left hand side and the right hand side are now the same. Ensuring that the total number of charge on the left hand side and right hand side are now the same. What are we doing here? We are trying to explain the concept of oxidation and reduction. We are trying to explain the concept of oxidation and reduction. And class, we're going to ask ourselves, is chlorine oxidized or reduced? When chlorine moves from Cl to Cl minus, has it undergone oxidation or reduction? Let me know in the comment section. When chlorine moves from normal chlorine to -1 chlorine, has chlorine been oxidized or reduced? Let me know in the comment section. Has chlorine been oxidized or reduced? When chlorine moves from 0 to -1, has it been oxidized or reduced? Okay, I'm seeing your comments. Some people are saying oxidized, some people are saying reduced. I'm seeing your comment. I'm seeing your comment. Oh, excellent. Class, because you don't have much time, exam is so close, I would have loved to test you more to see more of your answers. But we have to move forward. Class, chlorine has been reduced, clearly. You know why? I'll give you two reasons. Number one reason is that chlorine moved from 0 oxidation number to -1 oxidation number. Class, from 0 to -1 is a decrease in oxidation number. It is a decrease, and that is reduction. Reduction is decrease in oxidation number. Reduction means decrease in oxidation number. When chlorine moves from an oxidation number of 0 to -1, there's a decrease in oxidation number. But watch, there's an increase in number of electrons. Let me show you. Number of electrons here was 17,287. Number of electrons here was 18,288. So even though there's a decrease in oxidation number, there's an increase in number of electrons. This is how you know that reduction has taken place, class. When there's a decrease in oxidation number and when there's an increase in number of electrons. You know why I'm not explaining these other two? These two are simple because addition of oxygen, you easily know that this guy has taken oxygen, is oxidized. Removal of hydrogen is also obvious. These two are obvious. These last two, they are obvious. That is when oxygen is added and when hydrogen is removed. But class, these first two are not so obvious. Not all students understand that oxidation can also mean increase in oxidation number. Many students just think it's only when you add oxygen to an atom that oxidation has taken place. Many students only know one definition for oxidation: addition of oxygen, oxidation. No. Oxidation has 4 different definitions. Your JAMB, in fact, could be asked which of the is not true of oxidation. You must know the one that is true, so you can select the one that is not true. So oxidation is increase in oxidation number, which I've just explained now. Decrease in number of electrons, which I've explained now. Addition of oxygen, which is obvious. Nobody needs to tell you that one. Once you add oxygen to an atom, that atom has been oxidized. Removal of hydrogen. Anytime you remove hydrogen from an atom, you have also oxidized that atom. Either you are adding oxygen or you are removing hydrogen. Oxidation has taken place. Coming to reduction, decrease in oxidation number, you can see. When chlorine moves from 0 to -1, that's decrease oxidation number. Increase the number of electrons from 287 to 288. Removal of oxygen, obvious. When someone has lost oxygen, it has been reduced. Addition of hydrogen. When someone has gained hydrogen, it has been reduced. I hope we are still together. Are we still together? Are we still good? Are we good to go? Is the bus still clear? People are saying network. Oh, please, no false alarm. No false alarm, please. Good. You can see the board, right? Okay, let's fire down. Please, in case you are lost, this is an online class. Just rewind the video and watch again. It's an online class. This is not a physical class where you are, once teacher has taught it, you have missed it. No. If you think I was too fast, rewind the video and watch again. You can go back. You can rewind it and watch again. It's an online class. You have the power. You can watch what I just taught now 10 times until you get it. You can keep watching it 10 times until you get it. And it doesn't mean that because you are going back, you will now miss what I was teaching next. No. After you have finished watching what you missed, the video will still play everything you missed while you're watching that one. So nothing is lost. It's digital data. So please, anytime you are lost, why I'm rushing is that JAMB is closed already. Someone is saying I should be slowed down by this time. I'm not helping you. JAMB is 10 days, guys. If you just close your eyes and open it, you see yourself in the exam hall. Just close your eyes and open it to see yourself in the exam hall. No time again. So class, who are oxidizing agents and who are reducing agents? Oxidizing agents are agents that causes oxidation, while reducing agents are agents that causes reduction. Class, any agent that can carry out these four processes is an oxidizing agent. And any agent that can carry out these four processes is a reducing agent. So any agent that can cause increase in oxidation number, decrease in number of electrons, addition of oxygen, removal of hydrogen is an oxidizing agent. Any agent that can cause decrease in oxidation number, increase in number of electrons, removal of oxygen, addition of hydrogen is a reducing agent. But class, you know one funny thing? All oxidizing agents are always reduced. All oxidizing agents are always reduced. And all reducing agents are always oxidized. All reducing agents are always all oxidizing agents are always reduced, and all reducing agents are always oxidized. All oxidizing agents are always reduced. See, someone says, sir, be fast, you see? So one student said, be slow. One student said, be fast. Which one should we do? One student said, sir, please slow down. One says, sir, be fast. You see why I asked her to keep teaching? Let me just keep going. Let me just keep going. What we can do is that it's an online class. Rewind the video and watch again. Now, are you aware, class, that all non-metals, note, all non-metals are oxidizing agents. All non-metals are oxidizing agents. All non-metals are oxidizing agents. All non-metals, class, are oxidizing agents, except in their ionic state when they become reducing agents. Except in their ionic state when they become reducing agents. Except in the ionic state when they become reducing agents. Class, any non-metal you can think of is an oxidizing agent. Class, note, except in the ionic state, I will explain. When they become reducing agent, what does it mean? Class, who is a non-metal? Chlorine is a non-metal. Chlorine is an oxidizing agent. Chlorine is an oxidizing agent. And don't forget we said that all oxidizing agents always undergo reduction. All oxidizing agents are always reduced. Class, all oxidizing agents always undergo what? Reduction. They are always reduced. All oxidizing agents are always reduced. Class, that's why I didn't mean you had this information. I didn't mean you had this information. That all oxidizing agents are always reduced. That time I was asking you that what's happening here when chlorine became Cl minus. Without thinking, you would have known that its reduction has taken place. Because you will tell yourself, chlorine is a non-metal, and all non-metals are oxidizing agents. And oxidizing agents are always reduced. Simple. Simple logic. I'll come again. For those I always say I'm too fast. When I was asking you, remember I gave you this equation, I was asking you what is happening here? Is it oxidation or reduction? Some of you were commenting oxidation, some of you were commenting reduction, right? I didn't mean you had this knowledge that all non-metals are oxidizing agents. So you know that chlorine is a non-metal. And all oxidizing agents are always reduced. Meaning that chlorine has no other option but to be reduced. Why? Because it's an oxidizing agent. All oxidizing agents are always reduced. So you just say this reduction without thinking too much. But class, there's a big difference between chlorine and chlorine minus. Don't let them catch you in the exam. Because I told you that all non-metals are oxidizing agents. Class, chlorine is an oxidizing agent because it's a non-metal. But once chlorine transforms to Cl minus, to ionic state, it becomes a reducing agent. It becomes a what? So normal chlorine is an oxidizing agent. Charged chlorine is a reducing agent. Are we still together? Normal chlorine is an oxidizing agent. Charged chlorine is a reducing agent. So this agent is not carrying any charge. But once it becomes a charged chlorine, is a reducing agent. So we say all non-metals are oxidizing agents, except in their ionic state when they become reducing agent. Another non-metal is oxygen. Oxygen is an oxidizing agent naturally. Oxygen is an oxidizing agent. Of course, it's very obvious that oxygen must be an oxidizing agent because the oxidizing means addition of oxygen, right? So if oxygen itself is coming to you, it's coming to oxidize you because it's carrying its oxygen. Oxygen itself is coming to you, it's coming to oxidize you. So it's an oxidizing agent. But another reason why oxygen is an oxidizing agent is that it's a non-metal. Another reason why oxygen is an oxidizing agent is a non-metal. All non-metals are oxidizing agents. But when oxygen gains 2 electrons to become O2 minus, in ionic state, it becomes a reducing agent. So oxygen in ionic state becomes a reducing agent. But normal oxygen is an oxidizing agent. Please take note. Now, what of reducing agents? I want to note that all metals are reducing agents. All metals. All metals are reducing agents. But in ionic state, they become oxidizing agents. All metals are reducing agents. But in ionic state, they become what? Oxidizing. Who are examples of metals? Example: sodium, potassium, calcium, aluminium, etc. All metals are reducing agents. But in ionic state, they become oxidizing agents. Can you still hear me? Can you still see the board? Give me an update, give me an update, give me an update. Someone should give me an update. Can you still hear me? Can you see the board? Sharp, Omowumi, thank you. Omowumi, thank you. Yes. Rachel Igwe, thank you. Davido, what am I saying? Thank you. Yomi, thank you. Edafi, thank you. Let's go. So sodium class is a reducing agent because it's a metal. Just because it's a metal, it's a reducing agent. But when sodium becomes sodium plus, it becomes an oxidizing agent. So uncharged sodium is a reducing agent. All metals in their uncharged state are reducing agent. All metals in their uncharged state are reducing, but once they become charged, they become oxidizing agents. Let's keep going. Now write down electrolysis. 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 Electrolysis is made up of 2 words. Electrolytes and lysis. Class, electrolytes are ionic compounds. Electrolytes are ionic compounds capable of conducting electricity. Electrolytes are ionic or polar compounds. You can also call them polar. Electrolytes are ionic or polar compounds capable of conducting electricity. Class, how do you recognize an electrolyte? An electrolyte is usually made up of a metal and a non-metal. Electrolyte is usually made up of what? Made up of what? Electrolytes are usually made up of a metal and a non or electropositive species and electronegative species. Electrolytes are usually made up of what? Metal and non-metal or electropositive species and electronegative species. That's how you recognize an electrolyte. They usually form during what? Ionic bonding or electrovalent bonding. The compounds formed during ionic bonding, chemical bonding, you know you have ionic bond or electrovalent bond. Those compounds formed during ionic or electrovalent bond are electrolytes. So electrolysis comes from two words. Electrolyte, lysis means breakdown. So the meaning of electrolysis means electrolyte breakdown. Electrolyte what? Breakdown. Electrolysis. Electrolyte breakdown. Are you still with me? Class, why am I touching electrolyte? Someone said, what does polar mean? What does polar mean, class? Something is said to be polar when it contains two opposite ends, class. A compound is said to be polar if it contains two opposite ends. What do you mean by two opposite ends? Now it contains the positive end and the negative end, polar. A polar compound is a compound, or polar, anytime you hear the word polar, it means that it has both two opposing ends, a positive side and a negative side. What is non-polar? Opposite of polar is non-polar compounds are also called covalent compounds. Covalent compounds contain the same ends, that means minus minus or plus plus, but most time minus minus. When the two ends are the same, they are non-polar. But when one end is positive and the other end is negative, is what? Polar. For example, when you have a metal and a non-metal, a metal is positive, a non-metal is negatively charged, right? Metals produce positively charged ions. Non-metals produce negatively charged. So when a metal and a non-metal bond and they form a compound, that compound will be a polar compound. But when two non-metals bond, that compound will be what? A non-polar compound. Because two non-metals will produce two negative charges. When the charges are the same, it is said to be non-polar. When the charges are different, it's said to be what? Polar. I hope I've answered your question. Someone said, what is polar? Now let's move forward. So electrolysis means electrolyte breakdown. Breakdown electrolytes. What causes electrolyte breakdown? So let's define electrolysis. Is the decomposition of an electrolyte when electric current is passed through it. Electrolysis is the decomposition of an electrolyte when electric current is passed through it. Class, let us say, what are examples of electrolytes? Example of electrolytes, we have NaCl, A2SO4, NaOH. What is so special about electrolyte? They have a positive end and a negative end. For example, NaCl contains Na plus and Cl minus, polar. It must be polar. A2SO4 contains 2H plus and SO4 2 minus. NaOH contains Na plus and OH minus. You cannot be an electrolyte if you don't have two opposing ends. That's one positive and one negative. Very important. Very important. Class, many more. But let me show you something, class. When electric current is passed through an electrolyte and the electrolyte decomposes, we said electrolysis has taken place. Let us say we have what? An electrolyte, NaCl here, that dissolves. Let's have NaCl first. Class, this is the electrolyte. How do we pass electric current into the electrolyte? We use what we call electrodes. Class, electrodes are the mediums through which electric current is passed into the electrolyte. Right, there are electrodes. Electrodes. Medium through which electric current. Why is this topic very important? It comes out in both chemistry and physics. Please take note. You cannot escape, you cannot write JAMB as a science student and you will not see electrolysis somewhere. You cannot write JAMB as a science student and you will not see electrolysis somewhere. If it doesn't come out in chemistry, it will come out in physics. Same thing for gas laws. Gas laws is in physics and chemistry. Electrolysis, gas laws. Another topic that's in physics and chemistry is radioactivity. If you don't see it in physics, you see it in chemistry. Radioactive emission. I might teach that, I'll teach that tomorrow. Radioactive emission. Yes, of alpha rays, beta rays, gamma rays, alpha particle, the helium-4 atom, the beta particles. We'll do that tomorrow. There's no time. We'll do that tomorrow. That's nuclear fission. Nuclear fission. We'll look at that tomorrow. Class, topics that come out in 2 or more subjects, don't joke with them. Electrolysis is one of them. Electrodes are medium through which electric current is passed through the electrolytes. Electrodes are medium through which electric current is passed through the electrolyte. Class, you cannot take electric current to this place without using electrodes. And there are 2 types of electrodes. But let me see if you are still following. I hope I'm not teaching myself. Is the network still good? I hope I'm not teaching myself. Is the network still good? Is the network still good? Yes, someone said I will not live to the end. We forgot to take our commitment. If anytime before we start a class, we usually make a commitment. But JAMB is 10 days away, I was rushing. I will not live to the end. Type in the comment section. I will not live to the end. Make that commitment now. I will not live to the end. JAMB is just 10 days. After JAMB, you can sleep well. After your JAMB, you can sleep well. Don't worry, I'll give you guys a lot of break before we now enter post-UTME preparation. Because after blasting your JAMB, you need to also blast your post-UTME. But you have small break. You can sleep well. Then we'll start post-UTME very early. Some of you are rushing this JAMB. Don't rush post-UTME like this. You must start very, very early. Very, very early. So, but please, JAMB is 10 days away. Let us learn. Electrodes are medium through which electric current is passed through the electrolyte. There are 2 types of electrode. We have the positive electrode and the negative electrode. There are 2 types of electrode. We have the positive electrode and the negative electrode. The positive electrode is called anode. Negative electrode is called cathode. We'll soon get to that question I asked you. Where does oxidation take place? Where does reduction take place? A proper JAMB question they can ask you in JAMB. Where does oxidation take place? Where does reduction take place? The positive electrode is called the anode. And negative is called the what? Cathode. So, what does that mean? Follow me now. When the electric current is passed through the electrolyte, who is the electrolyte? NaCl is the electrolyte, right? Example of electrolyte, we have NaCl, H12NaOH. Let us use NaCl. When the electric current is passed through this electrolyte, NaCl, it will split up into its component ions. That's Na plus and Cl minus. Don't forget, electrolysis is the decomposition, right? Or breakdown, right, of an electrolyte. What causes the breakdown? When electric current is passed through it, right? It breaks down into Na plus and Cl minus. What now happens is that this is the electrolyte that's broken down. The ions will now find their paths. Who remembers in science that unlike charges attract each other, while like charges repel? Unlike charges attract, like charges repel. Unlike charges attract, like charges repel. So NaCl are split into Na plus and Cl minus. Don't forget there is a positive electrode and there is a negative electrode. There is a positive electrode, there is a negative electrode. What happens is that this negative and this positive will attract each other. Sodium will be attracted to the cathode and chlorine will be attracted to the anode. Why? Positive usually attracted to negative and negative usually attracted to positive. So the positively charged ion is usually attracted to the negatively charged electrode. And we are not surprised, right? Unlike charges attract. The positively charged ion is attracted to the negatively charged electrode, while the negatively charged ion is attracted to the positively charged electrode. What are positively charged ions called in chemistry? They are called cations. What are negatively charged ions called in chemistry? They are called anions. What if they ask you in JAMB? Now, what's the name of the ion that contains both positive and negative? They are called deuteriums. Deuteriums are ions that contain both positive and negative. When you contain only positive, you're a cation. When you contain negative, you're an anion. When you contain both, you're a deuterium. Yes, I like the energy. I will not live to the end. I will not live to the end. I will not live to the end. Now, moving forward. So, class, notice the cations go to the cathode. Cats. The name right? Cations go to the cathode. Anions go to the anode. And a discharge takes place. Class, a discharge takes place. When Na plus comes to the cathode, what happens? It will turn back to normal sodium. And when Cl minus goes to the anode, what happens? It will turn back to normal chlorine. Now I want to ask you a question to answer you. When sodium plus 1 goes to normal sodium, what has happened? Is it oxidation or reduction has taken place? And when chlorine minus 1 goes to normal chlorine, what has happened? Is it oxidation or reduction? This will help you to know what takes place at the cathode and what takes place at the anode. Because at the cathode, sodium came to the cathode and it wants to be discharged. The presence of sodium, Na plus 1, becoming Na, is called what? Class, don't forget, Na plus 1, sodium is a metal. Sodium is a what? Metal. And I told you that all metals are reducing agents, except in their ionic state, when they become oxidizing agents. I will repeat myself. All metals are reducing agents, but in the ionic state, they become oxidizing agents. So this sodium is ionic, right? Is an oxidizing agent currently, even though it's a metal. Normally, all metals are reducing agents, but because it's carrying a charge, it's an oxidizing agent. As soon as you carry a charge as a metal, you become an oxidizing agent. If you don't carry any charge, you're a reducing agent. But as the metal, once you carry a charge, you're an oxidizing agent. And what do we know about oxidizing agent class? I've told you. All oxidizing agents are always reduced. All oxidizing agents are always reduced. So class, it is clear that this sodium undergoes reduction. And where does this take place in the cathode? So we say that reduction takes place in the cathode. But even without this explanation, let us look at the chemistry involved, the stoichiometry involved. Class, sodium is plus 1. The oxidation number of this sodium is plus 1. This sodium does not carry any charge, so the oxidation number is 0. When someone moves from 1 to 0, there is a decrease in oxidation number. Go back to that note we wrote. What is the definition for decrease in oxidation number? Is it not reduction? Reduction. I'm giving you several ways why reduction is taking place here. I'm giving you several reasons. The first reason I gave you is that sodium is a metal, and metals in their charged states are what? Oxidizing agents. When metals become charged, they become oxidizing agents. And what happens to all oxidizing agents? They always undergo reduction. Oxidizing agents are always reduced. Reducing agents are always oxidized. I gave you that first reason. So because it's an oxidizing agent, it is always reduced. So even without looking at the equation, I can tell you that reduction is taking place here. But I'm looking at the equation. The oxidation number of sodium has moved from +1 to 0. There's a decrease. From 1 to 0 is a decrease. There's a decrease in oxidation number. And the definition for decrease in oxidation number is reduction. I hope we are still following. Forgive me if I'm a bit fast, but JAMB is putting pressure on us. Forgive me if I'm a bit fast, but JAMB is putting pressure on us. Good, good. Now, so we have understood that the cathode is where reduction takes place. Let's now come to the anode. Class, at the anode, this chlorine is a non-metal. And what we say about non-metals, all non-metals are oxidizing agents. But when they acquire a charge, they become reducing agents. So normally chlorine would have been an oxidizing agent because it's a non-metal. But because it's now carrying a charge, it now becomes a reducing agent. Elements, non-metals in their charge states are no longer oxidizing, they are now what? Reducing agent. And what happens to reducing agents? Reducing agents are always oxidized. Reducing agents are always oxidized. So class, even without looking at the reaction, I can tell you for free that there is oxidation taking place here. But now let's go to the reaction and see. From an oxidation number of -1 to 0 is an increase. Class, I know going to 0 might not look like an increase, but it's an increase. From minus to 0 is an increase. So there's an increase in oxidation number. An increase in oxidation number represents what? Oxidation. Let us keep going. Let us keep going. Class, we just explain to you the dynamics involved in electrolysis. Now, class, that's not all. This was easy and straightforward because we're dealing with just NaCl. What if NaCl was not alone? Because class, this NaCl now says in molten form, molten. Or say anhydrous. Anhydrous. What's the meaning of anhydrous? Anhydrous means that lacking water, no water. So this NaCl is not dissolved in any dilute solution of water. So sodium is discharged here, chlorine is discharged here. There's no competition for discharge yet. There's no competition for discharge yet. But watch. What if NaCl was with water, H2O? Because water is also an electrolyte. Water is also an electrolyte. Why? It has H plus and OH minus. What qualifies a compound to be an electrolyte? If it can produce two opposite ends, one positive and one negative, you are an electrolyte automatically. Any compound that can produce two opposite ends, one positive and one negative, is automatically an electrolyte. So water is an electrolyte. So if you have a solution containing NaCl in water, so when electric current is passed through the solution, it's not only NaCl that will split. NaCl will split into Na plus and Cl minus. H2O will also split into what? H plus and OH minus. Now these two positive ions will be attracted to the negative electron. And these two negative ions will be attracted to the positive. And only one can be discharged per time. Only one can be discharged per time. Who will first be discharged? Between sodium and hydrogen. And who will first be discharged? Between chlorine and hydroxyl ion. This is where we now come to what? The position of an element in the electrochemical series. The position of an element in the electrochemical series. If you are with me, say, sir, I'm with you. If you are with me, say, sir, we are with you. If you are with me, say, sir, we are with you. We are with you. Are we still together? Please, if you are lost, you have the right to rewind the video and watch again. If you are lost, rewind the video and watch again. It's an online class. Good. Good. More people have joined us. We are 75 on this live now. Well done, class. Well done, class. Potassium, sodium, calcium, magnesium, aluminium, zinc. iron, tin, lead, hydrogen and copper, mercury, silver and gold. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen and copper, mercury, silver and gold. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen and copper, mercury, silver and gold. This is how you memorize the electrochemical series. This is how you memorize the electrochemical series. This is how you memorize the electrochemical series. Who got the song? Who got the song? Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen and copper, mercury, silver and gold. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen and copper, mercury, silver and gold. Are we together? Are we following? Are we following? Are we following? Are we following? That is a simple way of knowing how to memorize the electrochemical series. Class, that's a simple way of memorizing how the electrochemical series. Class, as you are going down, the chances of discharge is what? Is increasing. As you are going down, the chances of discharge is increasing, while electropositivity is reducing. As you go down the electrochemical series, the level of electropositivity is reducing, but the chances of discharge is increasing. What does that mean? If there's a competition between someone like hydrogen and sodium, because hydrogen is lower than sodium, class, because understand that this continues here. Because I have some things here, that's why I continue like this. So the series continues like this. So class, hydrogen is lower than sodium in the electrochemical series. So if there's a competition between sodium and hydrogen, who should be discharged? Hydrogen will be discharged before sodium. So when sodium and hydrogen comes here, hydrogen gets discharged. Are we still following? Are we still following? Are we still following? Very simple song I used to teach my students how to memorize this. You can sing this wherever you're watching me from. You can sing this wherever you're watching me from, and you memorize it. Class, this will help you not just for this electrolysis. It will also help you for electropositivity series. This kills, use a stone to kill two birds. Class, in the exam, you could be asked, arrange the following metals in order of electropositivity. They put potassium, magnesium, hydrogen, silver. Who is most electropositive? Class, as you are going down, electropositivity is reducing. Potassium is the most electropositive element known in all 118 elements. Are you aware that we now have 118 elements in chemistry now? Yes, every day they're discovering new elements. I wonder how many elements we were told in secondary school. Every day science is evolving. We have 118 known elements. 8 new elements were discovered. And class, in all the 118 known elements, potassium is the most electropositive. You could be asked to arrange some elements in order of increasing or decreasing electropositivity. It's important that you're able to memorize this electrochemical series. Let me teach you the song. It might help you in the exam. You never know. Who knows? Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen and copper, mercury, silver and gold. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen and copper, mercury, silver and gold. That is the song for the electrochemical series, for electropositivity series. That is the song for the electrochemical series, for electropositivity series. Someone said network. Please, let it be your best. Hope it's only you. Can others hear me well? 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 Who can tell me the series for negative elements? Just like we have electropositivity series, we also have electronegativity series for electronegative atoms or radicals or elements. List the electronegativity series. Let me see in the comment section. Someone said I can sing it now. Excellent. That's the energy. Someone said I can sing it now. Someone said I can sing it now. Where are the others? Where are the others? Someone says, sir, sing the song one more time. Rewind the video, rewind the video. Rewind the video, rewind the video. Rewind the video, rewind the video. Are we together? Are we together? So, class, let's look at Faraday's law of electrolysis. Let's not look at something wicked. Let me just help you with the song one more time. Let's look at something wicked. It's simple. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen and copper, mercury, silver and gold. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen and copper, mercury, silver and gold. Class, Faraday's first law of electrolysis. Let's start taking the calculation. There is no time. Faraday's first law of electrolysis. Faraday's first law of electrolysis states that the quantity of electricity that is passed through an electrolyte is directly proportional to the mass deposited, to the mass of substance deposited at the electrode. What Faraday's law is telling us is that the quantity of electricity you apply on that you pass through an electrolyte will determine the mass that will be deposited. Class, don't forget that it's electricity that is passed through an electrolyte that causes the electrolyte to break down, to decompose. It is electric current that is passed through an electrolyte that causes it to decompose or to break down. So the quantity of electricity you pass through the electrolyte is proportional to the mass that will be what? Decomposed. So that Q will be equal to what? EM, where E is the constant. The mass decomposed electricity constant is E or Z. Sometimes we use Z, sometimes we use E. The mass decomposed. Class, important at this stage to note that the value of 1 Faraday is 96500 coulomb. The quantity of electricity that will deposit 1 Faraday is 96500 coulomb. What does this mean? What does 1 Faraday mean? 1 Faraday is used to represent each charge on the metal or the atom that is discharged. For example, let us say that magnesium is the metal that is discharged during the electrolysis. Magnesium is carrying a 2 plus charge. It will therefore mean that it will require 2 Faraday because the charge is 2 plus. To deposit a full 1 mole of magnesium, 2 Faraday of electricity will be required. And 1 Faraday of electricity is equivalent to 96,500 coulomb. 1 Faraday of electricity is equivalent to 96,500 coulomb. So 2 Faraday of electricity will be 2 times 96,500. That will be 193,000 coulomb. This is the quantity of electricity that will deposit 2 Faraday. For 1 Faraday, we have 96500 coulomb. For 2 Faraday, we have 193,000 coulomb. Class, if the metal was carrying a charge of 3 plus, it will require 3 Faraday. That will be 3 times 96500. That will be 289,500 coulomb. This is how you must understand this concept of Faraday's. Class, let me take a question that will help us to understand something. Let's really take a question now on electrolysis. Let's take a question on electrolysis. I hope the network is still good. Let us take a question. I want to take a standard JAMB question. Take this question down. Take this question down. Copper sulfate solution. Copper sulfate solution is electrolyzed using platinum electrodes. This is a standard JAMB question. Copper sulfate solution is electrolyzed using platinum electrodes. A current of 0.193 ampere is passed for 2 hours. How many grams of copper are deposited? It said take Cu to be 64 gram and take 1 Faraday to be 96500 coulomb. This is a JAMB question. Copper surface solution is electrolyzed using platinum electrodes. A current is 0.193 ampere. Time is 2 hours. Class must change these 2 hours to seconds. How do you convert from hour to second? Multiply by 3,600. 60 seconds make 1 hour. 60 seconds make 1 minute. 60 minutes make 1 hour. So from hours to seconds, multiply by 3,600. You're going to have 7,200 seconds. How many grams of copper are deposited, class? How many grams of copper are deposited? Class, we have the current and we have the time. There's something you must know. That the quantity of heat that passes through an electrolyte is a function of the current that is passed through times the time taken. Q equals to IT. Q equals to IT. Now the current here is 0.193 ampere. And the time taken is 7,200 seconds. Where's my calculator? So we're going to say 0.193 multiplied by 7,200. So the quantity of electricity that was passed through is 1389.6 coulomb. This is the quantity of electricity that was passed through the copper surface solution. But we're being asked, how many grams of copper will be deposited by this quantity of electricity? When you apply this quantity of electricity to the solution, what mass of copper will be decomposed? Don't forget, when we first define the electrolysis, anytime electric current is passed through an electrolyte, a mass of that electrolyte must be decomposed, must be deposited. So class, if this is the quantity of electricity that was passed through, what mass of copper in grams was deposited? Before we do this, we must ask ourselves one question. Copper as a whole is, the charge on copper is 2+. Class, when solving electrolysis, it's very important and key that you know the charge on each metal you are dealing with. That's why that table I gave you is still very important. Because apart from the sum, it contains the charge for most popular metals you'll be asked in chemistry, in electrolysis. Notice that the focus is more on metals. Why? Because electrolysis is very important in electroplating. Focus is more on metals. You really asked on non-metals. Just the metallic portions are the ones that usually deposited, usually asking you to find. So the charges are also very important. It's important you are conversant with the charge that each element carries. Because in the question, they do not tell you that copper is 2+. It's your job to know that. If they give you silver, you should know that silver is not 2+, silver is +1. If they give you mercury, mercury is 2+. If they give you gold, gold is +1. If they give you tin, tin is +2. You must know these things. So this table is very important again. I've written it before. Go and rewind and watch it now. Because this 2+ is what will determine the number of Faraday. Because 2+ means 2 Faraday. And 2 Faraday means 2 times 96500 coulomb. Why are we getting this? Because this is the quantity of electricity that will liberate a full mole of copper. And a full mole of copper is 64 grams. So 64 grams of copper will be liberated by this quantity of electricity, 2 times 96500. So if you get this charge wrong, you get the quantity of electricity wrong. 2 times 96500 will give you what? 193000 coulomb. This is the quantity of electricity that will liberate a full 1 mole of copper. What's 1 mole of copper? 64 grams. So 193000 coulomb will liberate 64 grams of copper. Now this is the quantity of electricity available now. 1389.6 coulomb. What mass will be liberated? Let's call it X, we don't know. If 19300 coulomb liberates 64 grams of copper, what of 1389.6 coulomb and what mass of copper will it liberate? Notice and repeat again, we have to first go and get the quantity of electricity that was passed through it. They did not give us direct, they gave us current and time. They don't give us our time in hours. You must change it to seconds. Then Q equals to IT. This This is the quantity of electricity that was applied on this solution. They're asking you what gram of copper will be deposited. But you must always know, class, that for one full copper, which is 64 grams, the quantity of electricity that will liberate 64 grams is 19300. Now, if this quantity of electricity is available, what mass will be liberated? We don't know, call it X, cross, multiply. So we have 19300 multiplied by X equals to 1389.6 multiplied by 64. Making X right of the formula, divide both sides by 193000. So 1389.6 multiplied by 64 equals 88934.4 divided by 193000. To give you what? 0.4608. This is the mass of copper that will be liberated by this quantity of electricity. Who got this before I got it? Sir, I got it before you got it. Let me see your hand. Sir, I got it before you got it. Sir, I got it before you got it. Well done, class. 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 If you use 63.5 as your mass of copper, you will end up having 0.457, which is still correct. Nobody has left. This is good. Well done, everybody. Well done, everybody. Well done, everybody. Well done, everybody. Another question. Another question. What number of moles of copper will be deposited by 360 columns of electricity? Take F as 96500 coulomb. What number of moles of copper will be deposited by 360 columns of electricity? I'll give you 1 minute to solve this. Take 1 minute to solve this. Take 1 minute to solve this. Let's go. Take 1 minute to solve this. 1 minute. I want to see the first answer. First answer. Who is done solving? Who is done solving? Who Who is done solving? First answer. First answer. You're asked to find number of moles. You're asked to find number of moles. I'm seeing a lot of answers. This is good. This is good. Let's do correction together. Let us do the correction together. One number of moles of copper will be deposited by 360 columns of electricity. Class, this is now number of moles they're asking us. Number of moles. 1 mole of copper. Class, we just did copper just now. 1 mole of copper is 2 plus. We need what? We need 2 times 96500, right? Coulomb. Which is what? 193000 coulomb. So for 1 mole of copper, we require 193000 coulomb. Now, how many moles of copper? What number of moles of copper? Let's call it X. Will be deposited by just 360 coulomb. If 1 mole will be deposited by 19300 coulomb, how many moles will be deposited by 360 coulomb? X. We don't know. Call it what? Anytime you have an unknown, you call it X. You cross 19300 times X will give you 193,000x equals 360 times 1 is 360. Now divide both sides by 193,000. Where's my calculator? So we're going to say 360 divided by 193,000. 1.865 times 10 raised to the minus 3. Moles. 1.865 times 10 raised to the minus 3 moles. Class, now let us move to one topic that JAMB loves setting a lot every year. Apart from electrolysis, JAMB loves solubility. JAMB loves solubility. Let's take a question on solubility quickly. Solubility. Please, for me to clean the board, you can always rewind and watch again. There's no time. There's no time. Let's take one question on solubility, class, quickly. Sorry. 9.8 grams of solid potassium chlorate was added to 40 cm cube of water and heated to dissolve all the solid. As the solution cooled, crystals of potassium chlorate started forming. At 66 degrees Celsius. The solubility of potassium chlorate at 66 degrees Celsius is therefore, I hope you are still with me. The The solubility of potassium chlorate at 66 degrees Celsius is therefore 9.8 grams of solid potassium chlorate was added to 40 cm cube of water and heated to dissolve all the solid. As the solution cooled, crystals of potassium chlorate started forming at 66 degrees Celsius. The solubility of potassium chlorate at 66 degrees Celsius is therefore before we solve this question, something just came to my mind now. There are actually 3 factors that determine discharge. In case you're asking the exam, let me just say it. On the electronics, you know we are rushing. A lot of things we are not touching because we are rushing. You understand? A lot of things we are not touching because we are rushing. No, there are 3 factors that affect the rate of discharge during electrolysis. Number 1 is the position of the ion, right? Which I showed you the electrochemical series. Position of ion in the electrochemical series. 2 is concentration of the ion. 3 is nature of electrode used. So you could be asking, which of is not a factor that affects discharge of ions during electrolysis? Which of is not a factor that affects discharge of ions? You must know the ones that affects before you can know the one that does not. These are 3 factors that determine who will be discharged and who will not be discharged. The position of ion in the electrochemical series, the concentration of the ions, and the nature of the electrode used. Yes. Some electrodes have high affinity for some ions, such that no matter where the position of that ion is, it will select that ion over any other ion. A very good example is mercury. Mercury loves sodium a lot. They form what we call the sodium amalgam. The sodium amalgam, yes. So nature of electrode, a lot of things. No, science book is so broad. There's a reason why many of your secondary teachers could not finish your syllabus, even in your 3 years in secondary school. But it's so broad, so broad. So many things. Your JAMB examiners have a plethora of topics to set questions from. Topics are so much. Your examiners have a plethora of topics to set questions from. What I would advise is this, like I have said earlier, make sure at this stage you're not reading any textbook. There's no time for textbook. A smart student goes straight to the JAMB exam question, the past exam question. Start drilling it. Start drilling it. Don't just solve questions. Take note of every option. Have an idea of everything they put in that option. Sometimes not that question that will come out. The JAMB rarely repeats their past question. They don't repeat past question. JAMB does not repeat because there are too many things to set. How would they not finish? Even in 100 years' time, they cannot finish setting everything in chemistry. So why would they repeat? There are topics that they have not taught last year. They want to touch it this year. There are topics they did not taught this year. They want to touch it next year. There are so many topics. It's so broad. We have not even entered metals and their compounds, non-metals and their compounds. They can bring funny questions. Which of the following gases is collected via upward delivery? Are we together? Which of this is usually collected during the industrial process? We have a contact process. Alba process of ammonia. We have metals and their compound, non-metals and their compound. Ores. We have metals and their ores. The ametite, the magnetite, the limonite. So it's so broad. Your examiners have a plethora of topics to bring questions from. That's what makes JAMB dangerous. There's so many things they can bring questions from. So many things. What I advise you to do, at least, but if you are a student that is well drilled on the exam, past exam question, one thing they don't change their language. They might change the question. JAMB does not repeat past question. Let me just tell you. If you're studying past question so that they will repeat a question, they will not repeat it. But you will understand how the same language, check from year to year. There's a way JAMB sets question. There's a direction. There's a way they like setting their question. If you study enough JAMB past question, you will have an idea of the language. So before you finish reading the question, you know where they are going already. Are we together? So at this point, you should be solving a lot of past questions. Because what past question will do for at least to put you in exam mode. Someone that's been doing past question before they use this 10 days and solve a lot of past question, that person is in exam mode more than someone that reading textbook. That person's brain is going to be faster, will think faster in the exam hall. Because you have been solving so many questions. So his brain will think faster, will be faster than you that you're reading textbook. You'll be solving with textbook speed. Because your textbook is slow. You have to be slow when you're reading textbook, right? 10 days to the exam, you don't need to be slow, you need to be fast. So textbook will slow you down. You need to pass the exam question. Pass the question will drill you, to challenge you. To challenge you topics that you don't even know that they existed. Things that you don't know that they existed. That's why our mock exam is only on Sunday, 12th of April. That mock exam, I've been sitting down to make sure I said something that is close to your main jam. I've been thinking, cracking my brain, inspiration, drawing inspiration, using the original jam past question, using a lot of things. I've just been brainstorming. So I can give you something solid. So that when you enter the jam, you say, I've seen something other than this. Your jam should be easier than our mock exam. Our mock exam should be harder than your jam. That's what I'm trying to achieve. So on Sunday by 8 p.m. on Sunday, this coming Sunday, 8 p.m. Like for example, I've already set physics. I've set physics already. But I'm going to set chemistry this night after this class. I'm not sleeping up. I don't joke with my students. After this class, I'm going to go and set chemistry exam. Then tomorrow I will set biology. Then next tomorrow I will set mathematics. I keep setting one subject per day so I can give it my best. I don't rush 2 subjects, so I don't go and set. I want to set something that when you write that exam, you say, yes, I'm writing JAMB, I'm writing. So if you, on Sunday by 8 p.m., tell your parents, tell everybody you're having a serious mock exam. After the mock exam, we'll then also do correction. We'll do what? Correction. And we'll put in our best. What I just advise is this. Make sure you don't rush. The way you're rushing this JAMB, don't rush your post-UTME like this. As soon as JAMB finishes, we'll give you 2-3 weeks break. And we're going to resume post-UTME classes early. Any topic I did not taught during JAMB, I will touch them very well during post-UTME. Because post-UTME is to test you that you know that you actually pass that JAMB very well. But why do they say post-UTME? To test that you actually pass that JAMB by yourself. Are we together? So don't worry, we'll put in our best to still give you the best. Now, take this formula for solubility. Mass of solutes divided by molar mass. Multiplied by 1000 cm3 divided by volume of solvent. Class. Sometimes they will give you, instead of volume of solvent, they give you mass of solvent. Don't bother yourself, it's still the same thing. What you just do is this will now be 1000 grams all over the mass of the solvent. So this can also be all 1000 grams all over mass of solvent in grams. Mass of solute, 9.8 grams of solid potassium chlorate. So mass of solute is 9.8. Divided by molar mass of, so what is molar mass of KClO3? Molar mass of KClO3. K is 39. For the atomic mass of potassium is 39. Chlorine is 35.5. Oxygen is 16, but we have 3 oxygen. 16 times 3, 48. 39 plus 35.5 plus 48. (122.5). So the molar mass of KClO3 is 122.5. So mass of solute 9.8, they give you that one. Molar mass is 122.5. Multiplied by 1000 cm3 divided by what is the volume of the solvent in the question. Was added to 40 cm3 of water. This is the volume of solvent. All over 40 cm3. So 9.8 times 1000 divided by 122.5 times 40. If you do the math very well, do everything very well, you should land at 2 moles per dm3. 2 moles per dm3. 2 moles per dm3. 2 moles per dm3. Who got this before I got it? Who got it before I got it? Who got it before I got it? Good, 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 good. Someone said, why was temperature given? Class, this temperature is a distractor. I know someone will be cracking their brain. How can I use this 66? Where can I put this 66? Class, in solubility questions, you are not to use temperature for anything. In solubility questions, you are not to use temperature for anything. In solubility question, you are not to use temperature for anything in solubility question. Please practice more questions on that. Practice more questions on that. Let me look at chemical equilibrium. Chemical equilibrium. Chemical equilibrium. Class, when is a reaction said to be in equilibrium? When do we say a reaction is in chemical equilibrium? Class, there are two conditions that must be met before we can say a reaction is in chemical equilibrium. One is that the reaction must be a reversible reaction. That means it can go forward, it can go backward. For a reaction to be in chemical equilibrium, there are two conditions that must be met. One, the reaction must be reversible. Two, the rate of forward reaction must be equal to the rate of backward reaction. The rate of forward reaction must be equal to the rate of backward reaction. These two conditions must be met before we can say a reaction is in chemical equilibrium. So class, if you have a reaction A plus B to give C plus D, and you see this double arrow means that this reaction can go forward and can also come backward. That means A and B can react to give C and D, and C and D can also react to give A and B back. Now, when the reaction is in equilibrium, is that the rate at which A and B is reacting to give C and D is the same rate at which C and D is reacting to give A and B. What do you mean by rate of reaction, class? The rate of a chemical reaction is the rate of change of what? Concentration. Is the rate of change of what? Concentration with time. Change in concentration over change in time is rate of reaction. Class, the rate of a chemical reaction is the concentration of species. Who are the species in a reaction? That's the reactant and the product. A reaction is made up of two parts, the reactant part and the product part. The reactants, right? And the what? Product. So the rate of a chemical reaction is the change in this delta means change in concentration of species. Who are the species? The reactants. Divided by change in time, that is time taken for them to react. That's the formula for rate of a chemical reaction. Now I'm telling you that the rate of forward reaction must be equal to the rate of backward reaction for the reaction to be considered to be in equilibrium. You could be asked in the exam, which of the following conditions must be met before your reaction is said to be in equilibrium? One, the reaction must be reversible. 2, the rate of forward reaction must be equal to the rate of backward reaction. What does that mean? If A and B is reacting in the same rate to form C and D is also reacting to come back to A and B, it means that there will now be a balance at the midpoint. An equilibrium position is established. An equilibrium position is established. Equilibrium position is established at the center. An equilibrium position is established at the center. So we have a reaction A plus B to give C and D. Let us include the stoichiometric coefficients. The stoichiometric coefficient of A is small a, B is small b, C is small c, D is small d. These are called stoichiometric coefficients. Just like when you have H2, 2H2 plus O2 to give 2H2O. This 2 before H is a stoichiometric coefficient. This is 1, O2, this 2. So let this be A, B, C, and D. It's called stoichiometric coefficients. That's number of moles of each component of the reaction. Class, it's what we call the equilibrium constant, Kc. The equilibrium constant Kc is a product, is a function of the concentration of the reactants, who are the of the product, who are the product C and D. Raised to power of their coefficient C raised to power C times D raised to power small d all over A raised to power A times B raised to power B. The equilibrium constant is a ratio of the concentration of the product raised to the power of their coefficient all over the reactant raised to the power of their coefficient. Class, we consider the left hand side the reactant, we consider the right hand side the product. It is product divided by reactants. So class, I think this reaction is, let me use this as an example. If this reaction was an equilibrium, let's put double arrow. If this reaction was an equilibrium, the Kc for this reaction will be concentration of H2O product raised to power 2 divided by concentration of H2 raised to power 2 times O2 raised to power 1. That's what I mean. Hope you are still there. Hope network has not taken you away. Some of you sleep must have carried you, who knows? Let's see who is still serious about this jam. Who is still serious about this jam? Who is still with us? Good, 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 good. The concentration equilibrium constant is the concentration of the product raised to the power of the coefficient 2 divided by reactant raised to the power of their coefficients. Now, class, remember what we said that because the rate of forward reaction equals to the rate of backward reaction, an equilibrium position is established at the center. It's now time to look at Le Chatelier's principle. States that, what is the Chatelier's principle? It states that if for any reason a reaction in equilibrium, if for any reason a chemical reaction in equilibrium, a chemical reaction in equilibrium is distorted or disturbed by any external factor, the system or reaction will move in such a way as to annul that disturbance. We move in such a way as to annul that disturbance. Lechetella's principle states that if for any reason a chemical reaction in equilibrium is distorted or disturbed by any external factor, the system or reaction will move in such a way as to annul that disturbance. As to annul that disturbance. What's the meaning of annul? That's to cancel that disturbance. If for any reason a chemical reaction in equilibrium, is distorted or disturbed by any external factor, the system or reaction will move in such a way as to annul that disturbance. Any external factor. It's now time to go to the factors that could affect equilibrium position of a chemical reaction in equilibrium. What are the 3 factors that can affect equilibrium position? Have you ever seen questions in JAMB where they will say, what is the effect of increase in pressure on the following reaction? You say shift to the left, shift to the right, no effect, none of the above. Some of you don't have any idea, you just used to guess. You used to guess, tell yourself the truth, you don't even know what to pick. You will just guess. Today I will teach you how to know what to pick. I'm sure you have done JAMB past question before. When they will ask you that when pressure is increased in the following reaction in equilibrium, what will be the effect on the reaction? They'll say shift to the right, shift to the left, remain at the center, no effect. Some of you don't know what to say. Let us teach you. As I said, there are so many things to learn. There are so many things to learn. Your examiners are very, very stocked. They are well stocked. In fact, they are well loaded with. In fact, it's very easy to say JAMB exam, but there are a lot of things. So, topics choke. Don't worry yourself. Topics do what? They choke. And it's just setting 40 questions. So, examiner has to find a way to set just 40 questions out of numerous topics. A lot of topics will be neglected. It's normal. Because the examiner cannot set questions on all the topics. If he set questions on all the topics, he cannot set 40 questions. You should know that. Only your SS1. If your examiner wants to take all the topics in SS1 only, it's more than 40, you know now. Many of you, your SS1 exam, you wrote more than 40 questions in your secondary school. If the examiner wants to take questions from only your SS1 topics, let us leave SS2 and SS3. Just SS1. You can set 100 questions. Only SS1. Now, JAMB is asking your examiner to set questions from SS1, SS2, SS3, and set only 40. You see? But there are some topics they will not joke with. There are some topics: electrolysis, solubility, gas laws, organic chemistry. They won't joke with those topics. Concentration of solution. I've taught those things before. If you're just joining us, there are some videos you should watch. I've taught some topics before. You must know how to balance equation. You must know how to reaction stoichiometry. They cannot set chemistry any year, and they don't bring questions of stoichiometry. That's reacting masses, mass to mass, mole to mass. Question must come out. Reaction stoichiometry. Something must come out along that line. Now, what are the factors that affect a reaction in chemical equilibrium? Factors. One of the factors that affects a reaction in equilibrium is concentration. Another factor that affects reaction in equilibrium is pressure. Or let's look at temperature first. Temperature. Then the last one is pressure. Class, these are the 3 major factors that affect chemical equilibrium. In case you asked in the exam, factors affecting chemical equilibrium. Factors affecting chemical equilibrium: concentration, temperature, pressure. Someone said catalyst. Class. Catalyst does not affect chemical equilibrium. What catalyst affects is rate of chemical reaction. Do not confuse rate of chemical reaction with chemical equilibrium position. Catalyst affects the speed of a reaction. What catalyst does is that it brings down the activation energy that's required for a reaction to proceed from reactant to product. You know that when a reaction actually takes place, there's what we call reaction mechanism. There's what we call reaction mechanism in chemistry. There's what we call the activated complex. When a reactant, A and B react, you know in chemistry, when you say A plus B gives C, this is what the general public knows, that A plus B gives C. But a real chemistry scholar knows that something happened before C was formed. An activated complex AB was formed. When A and B react to give C, they first join and form AB. It's called an activated complex. At this stage, it is not yet sure that C will be formed. At this stage, this product is very unstable. It could go back to AB, or it could come forward to C. What determines if this reaction will proceed to C or come back and scatter to AB is if the activation energy is met. Every reaction has a minimum amount of energy that must be attained before reactants can proceed to product. That minimum amount of energy is known as the activation energy. Now, if the activation energy is very high, like 5,000 joules, it might be more difficult for the product to be formed. So a catalyst comes in to bring down the activation energy so that the reaction can easily proceed to product. That is what the work of a catalyst. Who can tell me the opposite of a catalyst? If a catalyst helps a reaction to proceed fast, what's the name given to substance that does not allow the reaction to proceed fast? Tell me in the comment section. It could be asked in JAMB. JAMB is too broad. Too many things. Many things are entering my head. Too many things are entering my head. Upward delivery, downward delivery, you know. A lot of things. When the gas is collected over water, too many things. Sea breeze, land breeze. Your land breeze and your sea breeze is there. Hardness of water. What causes hardness of water? Chemistry is broad. Hardness of water is there. You know, we have hard water. A water that does not form lather with soap. It's broad. So that's why I said during our post-UTME class, whether your school is writing post-UTME or not, some of you, the school you're applying for is just training. But I advise that you still learn a post-UTME class because it will help you in 100 level. I teach 100 level in the university. 100 level, if you are not well grounded during this your preparation for JAMB, you will still go and struggle in 100 level. 100 level, you still do chemistry again, physics again. They just want to test you again. So whether your school is writing post-UTME exam or you're doing screening, I want to challenge you to test, make sure you prepare yourself before university. If you're planning to go to university, then prepare yourself now. Because when you enter school, there will not be time to learn all these things. School is every day there's activity. There's one thing or another. There's no time to actually learn. I deal with university and I'm talking from experience. Are we together? So there are some topics I will actually teach during the post-UTME. That's how we do it every year. There are some topics that we teach. Take some JAMB, go and write JAMB. Post-UTME will continue our post-UTME class and prepare you with some other topics. So by the time you get to 100 level, you are well grounded in everything. Now, I asked the question, what is the opposite of catalyst? It's called inhibitor. Inhibitor. The opposite of catalyst is called what? Inhibitor. Inhibitor. So a catalyst helps a reaction to proceed fast, and inhibitor slows down the reaction. Good. Someone just got it. Well done. I like this set. I love this set. Someone, Davidoish, what's his name? Davido Luafemi said inhibitor. Well done. Well done. Someone said on catalyst, not on catalyst. Okay, someone got it first. So Umwara Muhammad said inhibitor first. Well done. Well done, class. Well done, class. Now, class, let us show you how these three factors affect equilibrium position. Class, if you have N2 plus 3H2 to give 2NH3. Class, how does concentration affect equilibrium position? As it stands now, the equilibrium position is at the center. Anything you do to this reaction, the equilibrium position will shift to the left or to the right, based on the Chatelard's principle, that the system will move in such a way as to annul such disturbance. Class, as it stands now, this reaction is happy, everybody is balanced. If for any reason you come in and increase the concentration of this guy, you will increase the concentration of this NH3. If there's an increase in concentration on this right hand side, you have automatically disturbed the equilibrium of the whole system. And according to the Chatela's principle, the system will now react. Because you came, generally this system was balanced, and you came to increase ammonia only. When everybody was happy, both left and right, they're happy. You now increase only ammonia. The equilibrium position will always shift to the side where there's deficiency. Class, what that means is that the system will now start, because since there's an absurd amount of ammonia in the system, to balance this left hand side, the reaction will now start moving towards this side, so that more of these two guys will produce to catch up with the ammonia that was increased. So the equilibrium position will shift to the left. So if you are given this kind of question in the exam, given the equation in equilibrium, given the following equation in equilibrium, what will happen to equilibrium position if there's an increase in concentration of ammonia? The equilibrium position will shift to the left. And I'm explaining why. It will shift to the left because the priority will now be, okay, if this guy has been increased, what can we do to balance this guy? Okay, let us start producing more of this. Let us start producing more of this. Because this guy has been increased. Before everybody was balanced, you now started increasing this guy all of a sudden. The reaction will react in such a way as to annul or cancel that effect. That is the Chatela's principle. Now, if for any reason a chemical reaction is in equilibrium, is distorted or disturbed, if it's disturbed by an external factor, who is the external factor? You increase the concentration. One of the factors that affect equilibrium is concentration is an external factor. You came and increased the concentration of ammonia. There's a disturbance, right? The system or the reaction will move in such a way as to annul or cancel that disturbance. So, oh, you've increased this guy. The reaction says, okay, no problem. Let us move now. What do you need to do? Since this guy has been increased, let us move to come and create more formation of these guys. And the equilibrium position will shift to the what? Left. Leading to what? More formation of nitrogen and hydrogen. I hope that's clear, class. I want to see if you've gotten it. I'll give you another one. I want to ask you now, if we reduce the concentration of hydrogen, what will happen to the equilibrium position? Let me see the smart students among you. When there's a decrease in concentration of hydrogen, what will happen to the equilibrium position? If there's a decrease in concentration of hydrogen, what will happen to equilibrium position? Someone says shift to the right, shift to the right. People are saying shift to the right, shift to the right. Someone said increase. No, we're not talking about increase there. What will happen to equilibrium position? If there's a decrease in concentration, if there's a decrease in concentration of hydrogen, what will happen to the equilibrium position? If there's a decrease in concentration of hydrogen, what will happen to the equilibrium position? Will it shift to the left or to the right or remain at the center? Many of you are saying shift to the right. Class, let us analyze this very well. Before now, these two reactions were very okay and stable. All of a sudden, you're not going to reduce this guy. So you reduce this left-hand side, right? It means that this is where there's not deficiency on the left-hand side. Don't forget my statement. I said the equilibrium position always shifts to the side where there's deficiency to go and correct the deficiency. The equilibrium position usually shifts to the side where there's deficiency to go and correct that deficiency. Plus, there's decrease of hydrogen. So this is where there's deficiency. I mean, this guy is now lesser than this guy. What happens is that it will shift to the left. The position will shift to the left. Okay, hydrogen has been reduced. So let us work together to form more hydrogen so that they will balance. Because we reduce hydrogen's concentration. Let us work together to form more hydrogen. So everybody is going towards this left, to the hydrogen. Hydrogen is on the left. Let us form more hydrogen. What if we increase? So that's what happens. So equilibrium position shifts to the left. You see, it's very easy to miss this kind of question in JAMB. If you know all the formulas in JAMB and you don't get this, you've missed it. So you can clearly see it shifted to the what? To the left. Now, let us now look at this is how concentration affects equilibrium position. Let's look at how does temperature affect equilibrium position? Class, for temperature to have an effect, the reaction must either be endothermic or exothermic. For temperature to have an effect, the reaction must be either endothermic or exothermic. An endothermic reaction is a reaction in which the enthalpy change is positive. Exothermic reaction is a reaction in which the enthalpy change is negative. So for endothermic, the enthalpy change is positive. For exothermic, the enthalpy change is negative. We all know that endothermic reaction means a reaction that leads to the what when energy is absorbed from the surrounding. Energy gain, endothermic. Energy lost to the surrounding, exothermic. Class, I want you to note that when you are given a reaction and they told you to find the effect of temperature, they usually give you the enthalpy change of the reaction. If they put positive, it means that the reaction is endothermic. If they put negative, it means that the reaction is exothermic. But class, I want to remind you of something. Let us say they gave us this reaction now. And they gave us enthalpy change positive. I want to tell you that you must remember that this reaction is forward and backward reaction, is reversible reaction. Meaning there are two things happening in this reaction. The reaction is going forward, it's also going backward. The question you have to ask yourself is this. This enthalpy change that is positive, is it for the forward reaction or for the backward reaction? Or is it for both? Is it for the forward reaction or the backward reaction? Or is it for both? Class, this enthalpy change that is positive is only for the forward reaction. And I must tell you now that anytime you are given a reversible reaction with double arrows and they give you the positive in one side, it definitely means that the backward is negative. Anytime the enthalpy change of a reaction front is positive, back is negative. If front is negative, then back will be positive. No two forward and backward reaction have the same enthalpy change, class. If the forward reaction of a reaction is positive, the backward must be negative. And if the forward is negative, the backward must be positive. I hope I'm not too fast. I'm trying to say this as slow as possible, but still trying to look at the time because it's past 11. If the enthalpy change of a reaction, forward reaction, if the forward is positive, the backward must be negative. And if the forward is negative, the backward must be positive. What I mean is that both forward and backward cannot be negative, negative, or positive, positive. They must be opposite of each other. What's the importance of this, class? Because I want to tell you that anytime you increase temperature, note, increase in temperature usually shifts equilibrium position to the endothermic side of the reaction. Increased temperature shifts equilibrium position to the endothermic side of the reaction. Increase in temperature shifts equilibrium position to the endothermic side of the reaction. Why decrease in temperature? Class, there are only two things you can do to temperature. Either you increase or you decrease temperature, right? So the only two things they can ask you in JAMB is either they ask you for increase or they ask you for decrease. Increase in temperature shifts equilibrium position to the endothermic side of the reaction. Why decrease in temperature shifts to the what? Exothermic side of the reaction. That's the negative side. What does this mean, class? It means that anytime there's an increase in temperature, equilibrium position will always shift to the side that is positive. And when there's a decrease in temperature, equilibrium position shifts to the side that is negative. Are you still following? I know you are tired, but JAMB does not work with tiredness. So JAMB does not work with tiredness. That does not work with sleep. I think we have some new students here. So they are not used to sometimes that they don't know that we used to teach till sometimes 1 a.m. They don't know, they don't even know. You know, I made this class open. I just opened this class to all students. That's why. Because I'm seeing some conversation on that group. They are not sounding like my students. Yes, we used to have I have a private class. Some of you just joined us for mock exam. Some of you just joined our class for mock exam or past questions. I've been teaching my JAMB students since February, I think. Yes, February. Some people joined us February, some joined us March. Are we together? So when we used to have class, I don't open my class to everybody. I lock is a private link. But I decided to share this one to everybody because I just have a heart. I don't want everybody to pass. I don't want anybody to fail. And I'm seeing some comments. So I'm seeing a lot of laziness in the comment section. I know these are normal students. Nobody who says anything. We just keep learning. See when we finish. We have had class 12 midnight before. We have had class almost to 1 in the midnight. Ask some of them. But I'm seeing some very new, strange faces, strange comments that are showing that there are a lot of students that have mixed with our students. Please don't let them distract you. But although we'll soon round up because it's late, we'll soon round up. But please, I don't want to be saying things like, hey, when we stop, when we round up. No. Your JAMB is clear. I don't want writing JAMB. If I close this class now, it favors me, I can go and sleep. I'm not writing JAMB. I have nothing to lose. You're the one that is going to have JAMB problem, not me. But I'm trying to help you to pass. So instead of you trying to influence other people to be unserious like you, why not go and sleep? Some of you want to be unserious, but you don't want to be unserious alone. You want to carry people along with you to go and fail. If you are tired, don't go and sleep. Why do you want to announce it? Just go and sleep. Nobody's forcing you to be here. Carry you have your phone, you have the power, off your phone and go and sleep. It's you that's writing JAMB. It's not me that paid your JAMB for money. Go and sleep. Nobody forced you here. You have the right to leave anytime, but what you will not do is try to influence every other person to be unserious. Hey, I have time they go or time. Hey, you don't late or hey, 11. Please don't do that. This is why I don't like opening my class to everybody. Even when you try to help everybody, you now have people, unserious people or bad influence in the class. They'll just join. Can just join that's why I don't open my class to the public. Because anybody can just join. Bad influence can enter here. Anybody can start influencing other people to be unserious. When we used to have class, and nobody talks like this in our class. People always say, continue, fire down. But now I'm seeing a lot of bad eggs. Just this first time I open the class to everybody. If you want to go. Nobody forced you here. And this is also why I don't make my class free, because something that is free is not valuable. Because you are seeing it free now, you are just doing anyhow. If you want to go. Don't need to influence every other person with you. Go. You stop mentioning the level. Class, I'm tired. Why are you saying it? Just leave the class. You don't need to tell everybody. So other people will be tired. Other people now start feeling bad. Increased temperature shifts the equilibrium position to endothermic reaction. Decreased temperature shifts to the exothermic side. So what does that mean? I'll give you a question now to see if you understand this aspect. H2 plus O2 to give 2H2O. Now, enthalpy changes negative. Now, when the temperature of this system is increased, what will happen to equilibrium position? When there's an increased temperature, what will happen to the equilibrium position? What will happen to the equilibrium position? When there's an increase in temperature, what will happen to the equilibrium position? What will happen to equilibrium position? What will happen to equilibrium position when there's an increase in temperature? What will happen to what? Equilibrium position when the temperature is increased? When the temperature is increased, what will happen to equilibrium position? Will it shift to the right or to the left? I want to see that left or right, please. Left or right? When there's an increase in temperature, what happens to equilibrium position? When there's an increase in temperature, what happens to equilibrium position? Increased temperature, where does equilibrium position shift to? I'm saying right. What happens to equilibrium position when the temperature is increased? Class, when there's an increase in temperature, equilibrium position shifts to the positive side of the reaction. The equilibrium position shifts to the positive side. Class, and it's very clear that the right is negative. This is right now. Right is what? If the right is negative, the left must be positive. I told you that both forward and backward cannot be negative, negative. The left must be positive. Increase in temperature shifts equilibrium position to the positive endothermic side. Where is that? Left. So the answer is left. Those that said left, you are correct. Those people that said left, you are correct. Increase in temperature will shift the equilibrium position to the left, not to the right. Increase in temperature shifts to the left, not to the right. Shift to the left. Why? Because the left is where we have positive. If this place is negative, it means that this place must be positive. And if this place was positive, this side must be negative. I've told you that already, class, right? Good. Let's look at the third factor now, pressure. How does pressure affect chemical equilibrium? 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 Class, for pressure to be able to affect chemical equilibrium, class, number one, the reaction must be all gaseous. Before pressure can affect a reaction in chemical equilibrium, all the components of the reaction must be gases. All the components of the reaction must be gases, all gaseous. Two, make sure you read well, do your persuasion well. The top 3 students in the JAMB Master class, I'm going to reward you with a cash gift. I'm not talking about the mockers, I'm talking about the main JAMB. If you scored over 300, I'm going to reward you with a cash gift. A cash gift. And I'm not talking about 10K or 20K. Just to motivate you, I'll award you the 50K. Any of our students that scores above 300, I'm owing you 50,000 naira as a cash gift. Let me push you to go and read well. If you score above 300 in JAMB, I'm owing you 50,000 naira as a cash gift. So after your JAMB, you scored above 300. I want to push you. I want you to pass. You must pass. See, I'm going to spend my own money to help you to pass. I don't know you from anywhere. I'm not your father. I'm not your uncle. But I want you to pass. I don't know why. That's my job. I just want people to pass. I hate failure. If you score above 300, I'm owing you 50,000 naira. So go and read your JAMB. Jack your JAMB. If you score above 300, you send me your original result. I see it. I'll send you 50,000 naira. If you score 280 and above in JAMB, you didn't get up to 300, but you scored 280, I'll give you 20,000 naira as a cash gift. If you're my student and you score 280 and above, I'll give you 20,000 naira as a cash gift. If you score 300 and above, I'll give you 50,000 naira as a cash gift. Yes. Someone says, sir, what of those that are not your student? As long as you are learning now, you're already my student. I've already taught you. As long as you are learning now, you're already my student. As long as you are learning now, you're already my student. You are in my class, so you're not my student. Then what are you doing here? That means I should remove you now. Since you're not my student, so I'm teaching you in the midnight, and I don't consider yourself my student. So why am I suffering teaching you by? I should go and sleep then now. Someone that's teaching you by 12 midnight is not your teacher. He's not your student. Ha. Anybody that's taught you in this life is already your teacher. Even if it's best to taught you just once, it's your teacher already. It's a teacher already. So I'm just doing this to push you, to motivate you. I want you to pass. And if you cannot pass because you want to enter school, I need to pass because of money. I know it's small, but I need to do something. Say, yes, I passed my JAMB. This is more than your JAMB form money. You prove me, show me your results. I want to push you to pass your JAMB this year. I want you to pass. You must pass. Now, class, for pressure to have an effect, the reaction must be all gases. All gases. 2. The left and right hand side of the reaction must have different total number of moles. Class, there's something you see in a reaction and they say increase in pressure. What does it do to equilibrium position? You just say no effect. Why? Because that reaction does not meet the criteria for pressure to have an effect. For pressure to affect chemical equilibrium, these two conditions must be met. One, everybody in the reaction must be a gas. The reaction must be all gases, all gaseous. The reaction must be all gaseous. If you cite any solid inside that reaction, pressure has no effect. Class, they can shock you with a question like that. JAMB is so broad. This thing I'm saying, I might not even come out to because JAMB is too broad. The examiners are the boss here because there are too many things they can set. So the teacher can just try his best. The examiner is the boss. He has a lot of things to set from. They might be watching our life now, so you want to share this one, I'll go and say this one. Oh, you share this one, I'll go and say this one. They can surprise all teachers because topics are so much. But we'll try our best and hope on God. So pressure, for pressure to have an effect, one, the reaction must be all gases. Two, the left and the right hand side of the reaction must have different total number of moles. The total number of moles on the left hand side must not be equal to the number of moles on the right hand side. What do I mean? Class, look at this left hand side. The number of moles of hydrogen here is 2, oxygen here is 1, so 2 plus 1. So total number of moles on the left hand side here is 3 moles. What is total number of moles on the right hand side? 2. Right? Only water is here, 2 moles. For this type of reaction, pressure can have an effect. Do you know why? Because total number of moles on the left hand side and right hand side are not equal. If total number of moles on the left hand side and right hand side are equal, pressure has no effect, class. Please take it from me. When you calculate total number of moles on the left hand side and it's equal to the right hand side, pressure can have an effect. So total number of moles on the left hand side and right hand side must not be equal, they must be different. They must have different total number of moles. And they must all be gases. So you check the reaction. Is everybody a gas? Is everybody a gas? Yes. Know that water can exist in gaseous form as steam. So once everybody is a gas, it has met the first condition. Two, the left and right hand side must not have different number of moles. They are different. Good. How does pressure now affect equilibrium position? I'll round up here with this, so don't worry, you can go and sleep. How does pressure affect equilibrium position? Now listen carefully. Increase in pressure. Note, increase in pressure. Increase in pressure shifts equilibrium position to the side with lesser number of moles. Increase in pressure shifts equilibrium position to the side with lesser number of moles. Increase in pressure shifts equilibrium position to the side with lesser number of moles. Are we still following? Increase in pressure shifts equilibrium position to the side with lesser number of moles. Why decrease in pressure? Decrease in pressure shifts equilibrium position to the side with greater number of moles. Increase in pressure shifts equilibrium position to the side with lesser number of moles, while decrease in pressure shifts equilibrium position to the side with greater number of moles. Pay close attention. Pay close attention. Increase in pressure shifts equilibrium position to the side with lesser number of moles, while decrease in pressure shifts equilibrium position to the side with greater number of moles. Increase in pressure shifts equilibrium position to the side with lesser number of moles, while decrease in pressure shifts equilibrium position to the side with greater number of moles. Class, what does that mean? I want to see if you understand this point we just raised. If we increase the pressure of this reaction above, look at this reaction above. If we increase the pressure, what will happen to equilibrium position? Another thing you should know again is that JAMB questions are, now that JAMB is CBT, you are all not writing the same exact question. The question number Mr. A will see on Monday is different from the question Mr. B will see on Tuesday. Hope you know. Even on that Monday, we have different times. Some people are going 8 p.m., 8 a.m. Some people are going 12 p.m. Some people are writing 3 p.m. The exam questions are different day by day. So your science student you wrote on Monday is not what someone that wrote on Tuesday will write. It's not someone that wrote on Wednesday you write. So that's why when you see any class, learn. You don't know whether the exam criteria will come out in your own day. Topics are so much. When we increase pressure, what happens to the equilibrium position? So it's not even a fair exam because all of you are not writing the same question. All of you are not writing the same question, so it's not even fair. Someone can be lucky, their own day they give them a simple question, your own day they give you tough question. Who knows? Increase in pressure. What happens to equilibrium position, left or right? Some people are saying left. Class. In the left, we have 3 moles. In the right, we have 2 moles. Class, increase in pressure shifts equilibrium position to the side with the lesser number of moles. What side has the lesser number of moles? Is it the left or the right? It's the right. The right has 2 moles. The left has 3 moles. So you see that we are missing it. Increase in pressure shifts equilibrium position to the side with lesser number of moles, which is 2 moles. Increase in pressure shifts equilibrium position to the side with lesser number of moles, which is 2 moles. Good. Those that said right, you are correct. Increase in pressure will shift equilibrium position to the side with what? Lesser number of moles. Look at it. Increase in pressure shifts equilibrium position to the side with lesser number of moles. While decrease in pressure shifts equilibrium position to the side with greater number of moles. Please understand this and you will pass your JAMB. Go to your JAMB past question, look for more questions, take. Expand your horizon. Expand your horizon. Question can attack you from anywhere. Question can attack you from anywhere. I wish you guys all the best. I will release you this night. Out of all the topics we listed, I think there's only one that I've not done, which is still 90 over 100. It's not bad. We listed a lot of topics. Chemical equilibrium, we have done it now. Station reduction, electrolysis, solubility. Let's keep going. Let's keep going. Tomorrow, I will also come again and do some other topics. I will do today and tomorrow will be chemistry. Wednesday and Thursday, I will do physics. I will do physics Wednesday and Thursday. I will go to physics Wednesday and Thursday. I'll just try and be touching different topics just to help you in your JAMB. So see you tomorrow. Please go and do your JAMB pass. If you don't have original JAMB pass with you can purchase from us. Our students already have because it's part of the fee they paid. So they have it. But if you need original JAMB pass with you can message me and buy a copy. So you can use it to be studying. See you tomorrow, same time. Good night. This will be your last JAMB. I'm saying it by faith. This will be your last JAMB. You're going to score very high in this year's JAMB. I wish you guys all the best. Good night, everybody. Yes, yes. Good night, good night. Yes, yes, yes. You're welcome, you're welcome. Everybody say good night, good night. Welcome, you're welcome, you're welcome. Good night, good night, good night, good night. I'll just leave the live for 1 more minute so anybody that's still writing can write and I'll off it. Good night to you all. Good night to you all. Good night to you all. Good night, good night, good night.